Hello, greetings. In this video, we are going to look at electric circuits. So electric circuits is a closed path for electric current to flow. And we have some components of electric circuits. So the first component is the cell or the battery. And the cell is a single, but the battery is the collection of the cells. So when cells, two or more cells connected together, forms the battery. Now we have what is called a switch. We have an open switch and a closed switch. And we have the conducting wire. So this is the symbol of the conducting wire. And we have the light bulb. And this is the symbol of the light bulb. We have the resistance, and this is the symbol of the resistance. And the voltmeter, so the symbol of the voltmeter, and the ammeter, and the symbol of the ammeter. Now the resistor. The functions of the resistor is that it opposes the flow of the electric currents. And the ammeter, the voltmeter, is used to measure the potential difference, and the ammeter is used to measure the current flowing in the circuits. Now, the potential difference, or the voltage between 2 points in the circuits, is the work done or energy transferred per electric charge flowing through it. Now the EMF, the electromotive force, is also the work done per coulomb of charge supplied by the battery or supplied by the source. And the difference between the potential difference and the EMF is that when there is no current flowing through the battery, we measure the EMF, the maximum work done or energy supplied by the battery when no current is flowing through it per coulomb of charge. That is the EMF. And when current is flowing through the battery, we now measure the potential difference. And to calculate the potential difference, we use the formula. The potential difference is equal to the work done or the energy over the charge. So the energy is measured in joules. The energy or the work done is measured in joules. And the charge is measured in coulombs, which is given by a symbol C. And the voltage is measured using volts in volts. So this voltage here, 1 volt, is equal to now joules per coulomb. So the unit of the voltage can also be given as joule per coulomb. Now let's take an example how to do a calculation using this formula. What is the potential difference across a cell that provides 6 joules of energy to every 4 coulomb of charge passing through it? So now this question now demands us to use the potential difference formula. right, or the energy formula, because we can see that we have the energy mentioned and we can see we have the Coulomb mentioned and also the potential difference mentioned. So therefore, we can use the formula. The potential difference is equal to the energy or the work done over the charge. Now, what is given to us? We have the energy given and we have the coulombs given. Now, we're looking for the potential difference. So, therefore, the energy is 6 over 4, which is therefore equal to 1,5 volts. That is our potential difference. Now, let's take another example. What energy will 12 coulomb of charge get from 9-volt battery? We have coulomb of charge and we have volts, and then we were asked to calculate energy. So whenever there is a relationship between, whenever the question has to do with the coulomb, the potential difference, or the energy, then we have to use the formula. The potential energy, which is equal to the work done or the energy over the charge. So what energy? So that means we're looking for the energy. So we therefore say the energy is equal to V times Q. So therefore, what is our V? Our V is 9. And our Q is 12. So what do we get from this? We get 108 joules. Now the second question is, what charge passes through a lamp if the potential difference across the lamp is 6 volts and 12 joules of energy was transferred to the lamp? What are we looking for? Now we are looking for the charge. So if we are looking for the charge, then we therefore say that the charge is equal to, now we can also put this in a triangle to say that we have our energy and we have the potential difference and we have the charge. So if we are looking for the charge, we just have to say the energy over the work done. And if we are looking for the work done, then we multiply the 2. If you're looking for the work done, we multiply the 2. If you're looking for the potential difference, work done over the charge. So now therefore, we have to say the work done over the potential difference. We are looking for the charge. So therefore, our charge is equal to question number 2. Our charge is equal to, now the work done is 12 and the potential difference is 6. So which gives me 2 coulombs to be my answer. Now let's move to the currents. Now if we talk about the currents, the current is the rate of flow of charge. So the current is therefore equal to the charge over the time. So the current is measured in amperes, the charge is measured in coulombs, and the time is measured in seconds. So if we have 1 ampere, that is equal to now 1 coulomb per seconds. So the current can also be measured in coulomb, because we have coulomb on top and we have seconds underneath. So 1 ampere is equal to 1 coulomb per seconds. So whenever we want to calculate the charge, if we know our currents and our time, we can use the 2 to calculate our charge. And if we want to calculate our current and we know our charge and time, we can also use the 2 to calculate our current. So let's take an example of a question on this formula. What is the current strength of 5 coulombs charge? What is the current strength if 5 coulomb charge move past a fixed point in 2 seconds? So what are we calculating? The current. And then what do we have? The charge and the time. So therefore, we can use our formula. The current is the rate of flow of charge. That means charge over the time. And we are looking for our current. So, and what is given to us is the charge, which is 5, and the time is 2. So therefore, we shall get 2,5 amperes to be our current. 2,5 amperes to be our current. So now the next question is, calculate the number of electrons that move past a fixed point if a current of 5 amperes flows for 10 seconds. So now this question here, it demands us to calculate the number of electrons. So in electrostatics, we learned that question number 2, that whenever we want to calculate our number of electrons, we need our charge over the elementary charge on a single electron. But however, we do not know. We can calculate what we are given here. What we are given from this question here, we are given what you call the current and the time. And we know that the current is the rate of flow of charge. So based on these 2 here, we can calculate this. We can calculate the charge, this charge here. Because to calculate the charge, we can say the charge is equal to the current and then times the change in time. So we can use that formula to calculate our current. our charge, and then substitute the charge in to calculate our number of electrons. So therefore, our charge is equal to the current given here is 5 times the time is 10 seconds. So therefore, we are going to get the charge to be 50 coulombs. Now, getting the charge to be 50 coulombs, we therefore have to substitute it in. So now we can say the charge is 50 over negative 1,6 times 10 to negative 19. So now this gives us an amount of negative 3.12 times 10 to 20. Yes, and since we do not have a negative number of something, we therefore say our answer, our n, therefore n is equal to 3,12 times 20, 10 to 20 electrons. So that is all about this.